Our software is really focused on giving people a head start. So we focus on automation, and we do that through a branch of technology called computer vision. What might take you 4 hours or 4 weeks on a bigger job, we can do in a fraction of that time. Have a scan and you have a model and you want to know how closely those things match, we can do that element by element. So we can give you a lot of metrics because we basically fit a solid object to the point cloud and we've differenced the two. So we can always go back to that original and give you that difference. You basically put this on a Windows tablet, hook it up to a scanner, pull the data off, run it in the field, and in 10 or 15 minutes you'll have all the results you need. So hi, I'm Kelly with ClearEdge 3D. I always like to kind of summarize our space in the ecosystem as we're here to give you a head start. That's kind of how we see our job. Our software doesn't model every nut and bolt. Our software doesn't register all your scans together. Our software doesn't, give you a click a button, get a BIM. I'm sure you would all love that. That's not reality yet. Give us about another 20 years. We'll be there. I hope to be retiring by the time we have that done. But yeah, our software is really focused on giving people a head start. So we focus on automation, and we do that through a branch of technology called computer vision. And so basically, our software interprets scan data and tries to figure important stuff out for you with some level of automation. And so we kind of have a couple different tools that do this. EdgeWise is a fantastic tool if you're doing scan-to-BIM. We don't model the pumps, but we can automatically find the pipe runs for you. And what might take you 4 hours or 4 weeks on a bigger job, we can do in a fraction of that time. And yes, you still got to model the pumps. Yes, you still got to model all the bits and pieces, right? But if we get you to the 50-yard line, I'll do a sports analogy even though I'm not that big of a sports guy. If we get you to start on the 50-yard line, that's a heck of a lot better than starting out on the 20-yard line, right? You got well, depends on who's 20, I suppose. But even better, we might get you to the other guy's 20-yard line, right? So that's what EdgeWise does. We have a couple systems that we extract. We'll take a look in a second. We get those with a high degree of automation, and then you finish the rest of the job off in whatever authoring platform you're comfortable with. Whether that's Revit or Plant 3D or BDMS or something like that. Verity is a tool for us that focuses on verification. So if you have a scan and you have a model and you want to know how closely those things match, we can do that element by element and give you a bunch of cool reports, which is awesome for construction validation. It's also awesome if you happen to outsource your scan-to-BIM because you haven't bought EdgeWise yet. And you want to make sure that your consultant has actually done a good job meeting the spec. Super useful for that too. And then last, we have Rhythm, which is a tool that is very, very focused on a niche for floor flatness. Again, construction verification here, but floor flatness, beam camber, deflection, all that kind of stuff. So very focused on the concrete scope. So if you happen to be a concrete subcontractor, this might be of great interest to you. So I'll take a look at these in a little more detail. I'm not going to probably use up the whole 30 minutes because I think I can soup to nuts this stuff pretty quick. So hopefully I'll give you back a little bit of time. Yeah, so EdgeWise, actually, let's have more fun. Let's play the video. So essentially what the software does is it takes scan formats. It's vendor neutral. So you have a Leica scanner, you have a Ferro scanner, you have a Topcon scanner, you have an anybody scanner. We'll take it. The workflow almost entirely works with structured and unstructured data. There's one thing we can't do with unstructured data still, and that's the automatic pipe extraction, which is what you just saw on the screen behind me. So let me see if I can pause this for a second here. Oh. Why did it go into presenter mode? That makes it so hard. All right, anyway. So basically, all that stuff in the background that you can see, all that is automatic. So click a button, walk away, go get lunch, come back, 1,000 pipe runs extracted for you by the computer. That's the head start that we're talking about. Now, no algorithm's perfect. We've got QA/QC tools to look at it, but all of this stuff is basically zero human effort. And then we have some tools to help connect it, stitch it together here. So of course, scan data has shadows in it, and gaps in a pipe does not a pipe run make. So we can connect those things together. You've got some tolerance toggles and stuff you can wiggle around depending on how aggressive you want our algorithm to be. And then we have some other cool tools that will help you, let's call it rationalize it. So of course the pipe run is not straight, as you can see there on the screen, but maybe you're going into a design application and you really want it to be one big straight pipe run. We can do that for you and still average it across the whole span of points. And that's all based on tolerance. And then all of that stuff, you've now got your piping systems, you've got your elbows. This is from, I think, about 13 Faro scans. Took about 45 minutes to process, took about 15 minutes to do that, and it's ready to go into Revit. Not bad. Similar tools for structure. So we can crank through structure. Because there's so many shapes, computers kind of suck at things that people are good at, and people suck at things computers are good at. So trying to teach a computer to recognize the difference between two angles and a T, good luck. People are good at that though. So with structure, you tell it what type of profile it is first, extract it, and then we actually leverage the fact that structures are patterned typically. So to get that kind of big productivity boost, you're going to manually extract the structure in one bay, and then you tell it which way it repeats. And this is not a click button array. This actually uses that array as a basis for each individual component being refit to the point cloud. So it will refit it, resize it if necessary, and make sure that it's in the exact right place. So this is a smart array, I guess. That's how we get productivity and a head start on the structure side. And then we do similar things for ducting, for cable tray, and we also do walls. We don't do doors, we don't do windows, we don't do ceilings, we don't do floors. We do walls though, and we do walls really well as well. If you really want to look at in detail on any of these packages, we're up in that corner on the second floor. You can come track us down, but let's not watch the whole thing. But that's EdgeWise in a nutshell. It will go through and speed you up on specific scopes and get you into your authoring application really, really fast with very accurate as-built model information. So I like it. My background, actually, I was a customer before I joined the company. So this was something that we deployed in our scan-to-BIM team at the Beck. So fantastic tool. And with that, I'm going to segue into why I joined ClearEdge. Basically, I'd been asking for this for about 5 years, and they weren't doing it. And then I decided maybe if I joined the company, they'd do it. And they did, lo and behold. So what Verity does, again, is compare a model in Navisworks to a point cloud in Navisworks. So it's up to you to get the two on the same coordinate system. I've had a couple people ask me questions like, oh gosh, well does it like magically register the point cloud to the model? The answer is no. You don't want it to either, because depending on what it magically picked for the alignment, it might tell you things that are actually correct are wrong, things that are actually incorrect are right. So you don't want a relative alignment between the two. You actually want the two things to be lined up on some kind of intelligent coordinate system that you pick. So once you do that, though, you pull it in and essentially tell us what objects to pick and compare, tell us what point clouds to compare it to, and then every single one of those objects will be individually compared and fit to the point cloud. So if you've got a pipe and it's installed wrong, as you can see up there on the screen, clearly they were, we will go in and give you a detailed line item analysis of each of those pipes to say that this one is, completely in the wrong place. And this is where I wish I had the ability to jump ahead. And it's just not going to let me. All right, that's right. I'll fill up space. So fundamentally, this works with any model you can get into Navisworks. Has anybody here not been able to get something into Navisworks? What didn't come in? Okay, you can have some. Yeah, that is absolutely correct. Did you guys export it to something else to get it in? So you did get it in. All right. So we chose Navisworks because you can get almost anything in. Are we actually like, I feel like I'm watching a live demo right now because it looks like it's actually processing. This is funny. So we can take any geometry in because Navisworks can take any geometry in. Likewise, point clouds, we can take any structured point clouds. So if you're running your GeoSlam or you're running your NavViz or you're running something else, we have something that's kind of in technical preview. It's like a beta for us that you can do, but it's not quite as robust yet. So it's something we're testing out and trying to improve. But if you really want the best results, you're going to run a structured scanner. And typically people are looking for pretty tight tolerances. And for that right now, you want a structured scanner. Anyway, if you want to know if the steel's 1/8 of an inch off, don't do that with mobile data. But if you've got terrestrial data, basically what we'll do, like I said, is fit it. So the light magenta I-beam up there that you see, that is where it was supposed to be. That cyan blue one, that is where our software thinks it is, right? You can see that our software is pretty good. It's going to find that fit. And then for that beam, you can see every little bit in detail. So we'll give you a delta X, a delta Y, a delta Z. We'll give you total horizontal, total vertical. We'll give you rotation. We'll give you twist. So we can give you a lot of metrics because we've basically fit a solid object to the point cloud and we've differenced the two. So we can always go back to that original and give you that difference. So it's a very thorough, very robust way of doing QA/QC. It's metric-based. If you've got a spec for your consultant in some other country that did your model for you, and you've got a 2-inch spec, you can run all those components against that, and anything over 2 inches is obviously not meeting spec. Send it back. So 2-inch would be a pretty loose spec, though. We can also do some fun stuff. Of course, heat maps. We can compare as designed. We can compare as built. All sorts of stuff here to kind of get you to that soup to nuts workflow. We have exports that will go out to things like Procore, BIMTrack, BIM 360. So if any of these objects are issues that need to be elevated for field resolution, there's a direct path to most of the construction management platforms. We also can export the as-built geometry if you want to pull that in and do something. We can export the heat maps for the objects. So you can send them to a design consultant and they can go update their as-built model if they didn't get it installed right. So that is Verity in a nutshell. And then I'm just going to take a minute to talk about rhythm because I haven't talked to that many. What? I'm hearing whistles. Oh, whistle back here. All right. So you want me to talk more about rhythm? Oh, okay. All right. So rhythm, as I said, is very focused for floor flatness. So it provides a way for you to use scan data to replicate the ASTM 1155 report. So it basically simulates what you do in the field with a dipstick on a hard slab. It simulates that in the computer using scan data. Upsides to that, you can do it while the concrete's still wet. You can do it right after it's poured while it's still workable. So if there's an issue, you can go fix it before the concrete sets and you have to chip or fill, right? We also do heat maps and grid of points, all sorts of other really great stuff to help you document the flatness of a slab. You can compare change over time as well. Any of the point measurements, you can export them out and then pull them back in later with a second scan and rerun it, and we'll difference every point. So if you want to know if your slab settled, or if you want to know if, for instance, the bottom of some beams deflected after you poured concrete on them, all that can be done inside of Rhythm, and it can be done in the field. You basically put this on a Windows tablet, hook it up to a scanner, pull the data off, run it in the field, and in 10 or 15 minutes, you'll have all the results you need. So really fun. We've, like I said, we're back up here in this corner. You can come track us down. We're happy to demo any of these things for you. We've got some other cool stuff that we can show you that's kind of not quite ready to ship, but we've got beta versions of software, and we can always show that kind of fun stuff off if you're interested. So please, please, please come by, talk to us. And then I don't know if we got any questions, happy to take some, but otherwise, whatever time's left, you can have back.